Okay, so good day guys. Part 2 of our discussion about special right triangles. So we've already finished discussing the 30, 60, 90 right triangle, and we've also finished discussing the 45, 45, 90. So let's go to our next lesson, the 6 trigonometric ratios. Okay, so from the word trigonometric, okay, trigonometry, study of triangles, the study of the properties of the triangles, we're going to go okay, we're going to dive deep into trigonometry. Well, not that deep, but we're going to try to analyze the basics, okay, the basics of trigonometry in light of the 6 fundamental trigonometric ratios. So, this means that we're going to relate the angles and the sides of different triangles in order to create relationships that would enable us to understand and find the different side measurements of different triangles, okay, using the 6 fundamental trigonometric ratios. Okay, so we have here, the first one is sine. Okay, so how do we get sine? So sine is equal to the opposite side, okay, the opposite side of theta, okay, the opposite side of theta over the hypotenuse. Okay, so we have to condition ourselves, and you also have to really identify, okay, or try to remember that in the 6 fundamental trigonometric ratios, the value of theta, okay, the value of theta is dependent wherever it's placed. Okay, so if it's placed here, the value of sine theta is going to change, okay, because we now have a different opposite side, but the hypotenuse stays the same, but entirely the formula changes. So the formula, okay, the formula for the 6 fundamental trigonometric ratios always depend where the theta is found, or its relative position. The relative position of theta is important in determining the formula for our given fundamental trigonometric ratio. Okay, so sine theta is equal to opposite side A all over B, or the opposite side all over hypotenuse. The cosine theta is equal to C. Okay, so it's adjacent to theta. Okay, C all over B, the hypotenuse. Tangent theta is equal to A all over C, okay, or the opposite side all over the adjacent side. So that's tangent. Cosecant theta is equal to the hypotenuse all over the opposite side. Okay, so if you notice, guys, the inverse of sine is equal to cosecant theta. Okay, so sine theta, its inverse is cosecant theta. Okay, so if we have your sine theta is equal to A over B, then cosecant theta is equal to B all over A. Okay, so that also goes the same with secant theta. So secant theta is equal to B all over C, whereas cosine theta is equal to C over B. Okay, so we have these inverse. Okay, these are the inverses of our main and inverse functions for trigonometric ratios. And for cotangent, okay, so we just inverse tangent, okay, is equal to A over C for tangent, and cotangent theta is equal to C all over A, or the adjacent side is equal to opposite side. So I'm going to also teach you guys an acronym, okay, an acronym that will help you remember all of these 6, but the ones that we really use in trigonometric ratios are just these 3: the sine theta, the cosine theta, and the tangent theta. The rest, the cosecant, secant, and cotangent, we don't use that much often in terms of word problems in trigonometric ratios. But okay, I'm going to teach you a acronym. So it's called SO. Okay, SO katoa. Okay, SOH, so that you remember SOH, so ka toa, and then cho sha cow. Okay, so we have here so sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, toa is equal to opposite side all over adjacent side, cho is equal to cosecant is equal to hypotenuse all over the opposite side, secant is equal to hypotenuse over adjacent side for the sha, and cow is equal to the cotangent theta is equal to adjacent side all over opposite side. So, and again guys, the first three are the only ones that you will and we will most likely use for all of our word problems, the SOHCAHTOA. But if ever it arises, you can also use the inverse trigonometric ratio functions or ratios to check your answer for the main free trigonometric ratios. Okay, so let's try to what do you call this, apply. Let's try to apply this free main and the free inverse trigonometric ratios, so SOHCAHTOA and CHOSHA-COW. Okay, so a trigonometric ratio is the ratio of the side measurements of the hypotenuse and legs of a triangle using the sine, cosine, tangent, cosecant, secant, and cotangent trigonometric functions. So they all came from the 30, 60, 90, and 45, 45, 90 special right triangles. Okay, so let's try this one. Raisha is planning to create her new early morning exercise track for her dog, Toby, in their backyard. Given the dimensions of the park, okay, so on the right, okay, actually this is the dimensions of the exercise track. Okay, so it's the dimensions of the exercise track. On the right is in the shape of a 30, 60, 90 triangle. So find the value of x if the area of the right triangular track is equal to 100 squared meters. Okay, so we know that the area of the right triangular track is equal to 100 squared meters. Okay, so so that's going to give us 100. Okay, so that's going to give us 100 is equal to 1/2 base times height. Now we just have to find the value of the base and the height in order to solve for the value of x. Okay, so since this is a 30, 60, 90 triangle, since 30 again is equal to s, the 30 degrees, the 60 degrees is equal to square root of 3 times s, and the 90 degrees is equal to 2s. Therefore, since 30 here is equal to x plus 1, therefore the 60 degree angle is equal to the square root of 3 times x plus 1. And for this one, for the 90, we're going to get 2x plus 2. Okay, so there you go. So we already know the base, so it's 2x plus 2. Okay, so that's the base. Okay, so we can solve for the value of x. Okay, so to solve for the value of x of our given figure here, let's use the given that the area is equal to 100 meters squared. So area is equal to 100 meters squared. And we know that for solving the area of a triangle, it's equal to 1/2 base times height. It's been given that QU is the height of the figure, and we know the height of the figure, it's square root of 3 times the quantity x plus 1, or square root of 3x plus square root of 3. And we also know the value of the base, so that's UI, and it's it's UI and it's equal to x plus 1. Okay, so now we can solve for the area or the value of x. So this will give us 100 is equal to 1/2. Okay, the value of the base is x plus 1, and the value of the height is square root of 3x plus square root of 3. Okay, so this will give us 200 is equal to x plus 1. Okay, so let's try to multiply. So this will give us 200. Okay, so we're going to multiply the entire equation by 2 to cancel 1/2. So this will give us 200 times this binomial. Okay, x times square root of 3x, so that's going to be square root of 3x squared plus 2 square root of 3x plus 3. Okay, so therefore we have this, and to solve, so this is square root of 3. To solve for the value of x, we have to equate this entire equation to 0. So this will give us square root of 3x squared plus 2 square root of 3x plus square root of 3 minus 200 is equal to 0. And if you use MS Math Solver, or you can also use Symbolab, or you can also use the quadratic formula, okay, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, or you can also use your calculator, we will get that the value of x, okay, so it will have two values, and it's going to be equal to 9.75 or negative 11.75. And since we cannot have a negative value, therefore the value of x is equal to 9.75. To solve for the perimeter, okay, so we just simply have to substitute the value of x, which is equal to 9.75. So ui is equal to 9.75 plus 1, okay, 9.75 plus 1, which is equal to 10.75. And QU is just going to be square root of 3 times 10.75, okay? And QI is going to be equal to 2 times 10.75. Okay, so square root of 3 times 10.75, okay, times 10.75, so that's going to give you 18.62. Okay, and 10.75 times 2, so that's going to give us 21.5. And if we add these three measurements, okay, 21.5 plus 18.62 plus 10.75, we're going to get 50.87. So this is the perimeter. Okay, this is the perimeter of the triangle QUI, 50.87 centimeters, and the value of x is equal to 9.75 meters. Okay, let's check another problem. Okay, so we have this one. Dante wants to determine the length of the side of the measurements of his triangular vase. The top view of the vase is shown. Find the measurement of the hypotenuse and the shorter side of the special right triangular vase. Okay, so this is going to be easy. So since 60, okay, so since we have here 30, again is equal to s, 60 is equal to square root of 3 times s, and we have here 90 is equal to 2s. We want to solve essentially for 90, the hypotenuse. So we have here 60, so the opposite of it is 19. Okay, so that's 19 centimeters. So therefore, we have here, we want to know the value of s. So that's going to be 19 is equal to square root of 3 times s. And if we divide both sides by square root of 3, therefore s is equal to 19 square root of 3 all over 3. Okay, 19 square root of 3 all over 3, or that's simply equal to 10.97. Okay, s is equal to 10.97 centimeters. Since we want to know the value of the hypotenuse of Dante's triangular vase, so therefore we're going to have to multiply that to 2. So that's going to be, okay, 19 times square root of 3 all over 3 times 2. Okay, so that's going to give us 38 square root of 3 all over 3, or 21.94. Okay, so therefore, okay, the hypotenuse, okay, the hypotenuse of the vase is 21.94 centimeters, and the shorter side is 10.97 centimeters. Okay, so there you go. That's the answer. Okay, so let's try some more problems. Okay, so Diana wants to create the perfect sail for her small riverboat. She plans to have the shape of the sail similar to a 45-45 special right triangle. 45-45-90 special right triangle. Okay, so this one is 45-45-90. Find the perimeter of the sail given that the area of the entire sail is 20 squared meters. Okay, so how do we do that? Okay, so first we set up the formula.